We press buttons and we flip switches. Our lights come on and our equipment works. While it may sound simple, electricity itself is complex, and the process of delivering electricity is even more intricate. Let's take a look at the system that brings electricity to your business. Electricity can be generated in a number of ways, including power plants, wind farms, and solar panels. Today, most of our electricity comes from power plants. As power leaves the plant, it goes through a substation where a transformer increases the voltage. Then it can travel long distances on transmission lines. As the electricity nears the area where it will be used, it goes through a distribution substation. Here, transformers step down the voltage so the electricity can travel on smaller distribution lines. Then the electricity travels through distribution lines to your neighborhood, where small transformers reduce the voltage again. Now it's ready to use in your business. The electricity connects to your facility through a service drop. It passes through a meter that measures how much electricity you use. Let's discuss the process in more detail.
American Transmission Company owns the transmission system that serves MG&E. They have a single focus: transporting electric power from where it's generated to where it's needed. ATC was formed to ensure that all of their customers get comparable service. Their customers include electricity producers and electric distribution companies. So for MG&E, they serve both to carry the power we produce in our generation system and to deliver power to our distribution system. Typically, the transmission lines are coming from generating stations, and they're stretching across the state to other substations and cities and interconnecting those substations to take the power where it's needed.
ATC's transmission lines range from 69,000 volts to 345,000 volts. These high-voltage lines connect to MG&E substations. Equipment in our substations lowers the voltage and sends electricity out to the distribution lines.
This substation has three 138,000 volt transmission lines coming into the sub. The transmission line would enter here, go through the set of disconnect switches, through the circuit breaker, and from the breaker it'll go to the buswork. The purpose of the buswork is to distribute the power to the various components of the substation, and some of the power will also feed to our transformer. This transformer steps to 138,000 volts down to 14,000 volts, and you need to do that so you can safely transmit the power to our customers outside of the substation. The last step here is for this 14,000 volt power to feed down these black cables on this riser structure underground into the basement of our switchgear building, and it'll go to another bus, and from there various circuits will tap off that bus. Those cables will again feed underground, down the driveway, to the road, and up poles to distribute to our customers.
Let's move inside the switchgear building at the substation and learn more about how it's connected to our operations center.
Our operations center has complete oversight, control, and monitoring of all of our equipment that is located in the substation. Therefore, if we have a problem, an alarm, we have a piece of equipment fail, wildlife gets in the substation, trips it out, they have immediate response time as far as knowing what exactly is going on, the appropriate personnel to dispatch, so that we can get a timely response. The purpose of switchgear in the substation is to take the power from the substation and distribute it to the distribution feeders that are served out of the substation.
The electricity leaves the substation and feeds into our distribution system. It may continue its journey to your business through underground or overhead lines. An important device in that system of lines is called a recloser. Reclosers are strategically installed around our service area. They help maintain electric reliability for our customers. If an electrical fault occurs, like a lightning strike, the recloser will suspend power for 3 seconds. During this process, you may see your lights blink. If the fault clears within that time, the recloser returns normal power to the lines.
Several key components to our reclosers. So obviously you see the 3 tanks up there, and those are the mechanical pieces of our reclosing devices. Above that, you have some switches. So we can actually bypass that recloser, and we can work on that recloser while keeping electricity flowing. The other thing that's a key is at the bottom of the pole, and then the gold antenna is kind of the brains of the recloser. We program different settings into the brains of it at the bottom of the pole, and then the antenna actually sends a signal to our operations center. So our operations center has control over that recloser. They can actually open and close it, and they can also monitor it. So if we have any activity on that recloser where we do have a trip and a reclose, they do know that that actually has happened. If we do have a fault on our circuit, and it's a permanent fault, the recloser opens, it does stay then open, and then only certain number of customers are out of service. It's not the entire circuit.
So we have equipment in place to make sure that interruptions in power affect a minimum number of customers, but outages still occur, and we study them to determine if additional improvements are needed. Continuing our story, the power moves through the distribution system, through another transformer, and to your meter. The electric meter is a complex piece of equipment, and it provides an economical way to measure the energy a customer uses.
There's a number of things that we need to consider when choosing the proper meter for a customer. The first thing to take into consideration is the rate schedule. That defines what data is required to properly bill that customer. The second thing would be the type of service. Is it a single-phase service or is it a three-phase service? And then you have the service voltage. All those items are needed to make sure we get the proper meter in place for that customer. We have a dedicated, highly skilled workforce making sure the meter's metering accurately. The meters that we purchase meet all applicable metering standards, and our test equipment is certified annually.
There's another part to this story, the people and systems we rely on to oversee this complex process. Much of that work happens in our operations center.
The operations center is kind of like the air traffic controllers of the distribution system, both gas and electric. The operations center is staffed 24/7. The operators here work rotating 12-hour shifts.
Distribution Ross. That's going to cover 28-Yankee 7-Echo 7.
One of the functions down here in the operations center is to make sure that everything is within the appropriate limits. We make sure that voltages are at the appropriate level and that all the gas pressures are in check, both for the safety of our equipment and for you, the customer. There's maintenance that we perform constantly, all the time, as part of our normal business. So our switching desk over here coordinates with the line crews to perform system switching to isolate certain pieces of equipment. That happens every day, unbeknownst to all of us customers who receive uninterrupted power during that period. We get alerted to problems on the electric system in various ways. It could be the first thing that we know about is a call from a customer. We coordinate closely with the 911 center. If it's something that we pick up on our telemetry system, the operators here will get an alarm indicating that there's a problem. We have a very advanced energy management system that we call the EMS. It monitors about 28,000 points throughout the MG&E service territory. All the individuals have access to more or less the same systems, especially the outage system. We all work together to make sure that everybody operates their piece of the puzzle to resolve the outages quickly and efficiently.
The equipment, processes, and procedures needed to bring electricity to your business are extremely complex. MG&E understands these systems, and we work hard to use them efficiently and safely. We take seriously our responsibility to provide reliable energy services. We are committed to providing the power your business needs, when, where, and how you need it. Everyone at MG&E appreciates the opportunity to be your community energy company today and for tomorrow.